Hi everyone, you're watching the Space Channel. One day, one of the subscribers to our Telegram channel sent us the following question. If we build a huge spacecraft or station with a very large mass, would it have gravity? For example, on the Death Star from Star Wars or the Citadel from Mass Effect. So let's figure this out together. In George Lucas's Star Wars films, the Death Star is a gigantic military space station capable of destroying entire planets. According to Star Wars lore, the diameter of the first Death Star in Star Wars, Episode 4, A New Hope, was about 100 kilometers. The second Death Star, whose construction is shown in Episode 6, Return of the Jedi, had a diameter of roughly 160 kilometers. From here on, we'll go with the 160-kilometer figure, because a station of that size would generate a stronger gravitational pull. A spacecraft of that size would indeed have its own gravity due to its considerable mass, but it wouldn't be very noticeable. The thing is, the Death Star isn't a solid metal sphere. Schematics shown in parts of the franchise and in games set in the Star Wars universe indicate that the Death Star is largely hollow inside. Moreover, a diameter of 160 kilometers isn't large even compared to dwarf planets. Therefore, the station's mass wouldn't be all that large by the standards of planets and moons, so its gravity would be extremely weak. For example, Mimas, Saturn's moon, has a diameter of 400 kilometers, and its volume is filled with material. The acceleration due to gravity on its surface is only 0.7% of Earth's. You'd notice such an acceleration on Mimas's surface, mainly from how extraordinarily slowly objects you let go of would fall. The Death Star is much smaller and lighter, so detecting any pull at its surface would be exceptionally difficult. Moreover, as you move closer to the station's center, the freefall acceleration would decrease, and at the very center, it would vanish altogether. Attempting to build a spacecraft so huge that its own gravity would match even the moon's is absurd and doomed to fail. A craft that could generate that kind of free-fall acceleration while being mostly hollow inside would have truly colossal dimensions, far larger than the moon. And getting it moving and controlling it in flight would be incredibly difficult because of its enormous mass. In fact, to keep such a ship from coming apart during maneuvers, you'd have to reinforce its structure with materials so strong that we can't produce them today, and quite possibly never will. Otherwise, inertia would simply tear the ship apart the moment you tried to turn. Additionally, gravity would create enormous pressure deep inside the ship, placing an immense load on the hull that would simply destroy it unless the structure were reinforced. A step that, as I've already said, is unlikely to be feasible. Moreover, even if you managed to reinforce the hull and it withstood the pressure, people wouldn't. The air deep within the ship would also exert tremendous pressure, enough to crush any human being. As a result, people could remain only near the surface of such a vessel, which automatically renders most of its volume uninhabitable and therefore pointless. So, answering our subscriber's question, we can say that the self-gravity of spacecraft like the Death Star would be so small as to be negligible. In the fictional Star Wars universe, people have developed other ways of generating artificial gravity, which makes sense since perfectly normal gravity is present aboard Imperial cruisers and even on small ships like the Millennium Falcon. As for the Citadel from Mass Effect, that's a topic for a separate video, which we'll make if this video gets 500 likes. That's all from me for now. If you enjoyed this video, give it a like and subscribe to our channel. Have a great weekend, and see you next time.